Okay. Yeah, Jen, I can do that. I saw that in the chat. I'm going to do kind of an overview of the test, and then I'll get to specific questions, like the ones Jenna is asking. Once I go over just an overview of all the topics. Not a big deal, but give me just gosh darn it, give me 1 second. Okay, so first off, I know you've heard this for the past month, but the final will be not tomorrow, but 2 days from now on Friday from 8 to 5. A few of you had email me to make accommodations because you don't get off work till 5 o'clock or 6 o'clock. That's fine. Just get with me. I don't mind giving you extra time, or moving the due date time back. You do have 2 hours to complete it. There's actually, I believe, 39 questions, not 40 questions. You've got 2 hours to complete. Remember, your final grade replaces, or your final exam grade replaces your lowest regular test grade. So it really counts as 2 tests. Now, of course, if that final grade is lower than all your other grade, or your regular tests, it just won't replace it. So for almost all of us, it will count twice. But if for some reason it's lower than all the other ones, it just won't count. I know I've gone over that before with you guys. I'm just going over it again so we understand that. Also, contact your advisor as soon as possible for you guys that are taking classes in the spring. Now, if you're graduating, congratulations on graduating and moving on to the next academic and life endeavor. But if not, you need to get with your advisor ASAP. I'm going to tell you, I've been advising students the last few weeks, really right before Thanksgiving and now this week right after. And some of the classes are filling up, especially the online stuff. So I would get with your advisor as soon as possible so you can make sure that you don't have that issue where a class is full before, or just get with him before all the classes get full. Okay. Okay, yeah. So first I'm going to go over just all the topics that are on the exam. I did this with another class, so I'm stealing what I already wrote down. But at least this gives you an overview. This is not in any way in order. When I made this today, it was for the other class. Actually, it was yesterday. When I made this, I kind of just went through the test. I was looking at it and just kind of made the kind of buckets that are covered for each topic. So after that, I'm going to hit any and all examples. And I can stay even longer if you guys have a lot more questions. It does not matter at all. I've got nothing going on right after this class. So let's see. First, so this is just all the content. With matrices, now this is what we went over Monday. You guys are Monday, Wednesday, right? Yeah. But this is what we went over Monday. You got to be able to find the inverse. Remember, it was really easy in the calculator. You got to be able to multiply them. Understand their order. I would say their order and position. Like remember the position like A21 and A12, all that. If you get the homework, you know what I'm talking about. And then understanding the equality and then the addition and subtraction. Just the stuff we went over on Monday. All the stuff we went over Monday about matrices will be on the test. Okay, it is covered on the test. And then the next thing that now I'll tell you, my order might be different than your order. So don't assume this is the order that'll pop up when you're taking it. But next, the biggest bucket really is functions. College algebra really is centered around functions. And so the first thing with functions was just determining if we had a function, right? If it was a graph, it passed the vertical line test. If it was an equation, when you put in a value, you get back one and one value, only one value. Remember one x value. Each x value goes to one and only one y value. That was the main rule. And you got to find the domain. We did this with a graph. I should put that on there. Uh-oh. You're getting a little more info than the other. Given a graph and then also given an equation. So given a graph, it's where all the x values exist, right? And then also given an equation, how to find it. Or if we had those 2 red flags going on with the x's in the denominator, or we had the square root, how to find it if we had the square root. And then identifying where the graph was increasing, decreasing, or constant, that pops up. Finding a straight line, y equals mx plus b, that was a topic we hit this semester. and then finding inverses, compositions, and transformations. That was actually kind of out of order of how we covered it, but that was, I believe, the second test, maybe the third test. That might be the third test, where we found the inverses, the compositions, and the transformations. And then we got to quadratics. Now, it was quadratic functions. You could put this bubble in functions, but they had their own kind of special place, and they're really emphasized on this test. So you've got to know how to solve a quadratic. What I mean by that is solving either given as a function, solve for the x-intercept, so kind of like what Jenna was asking about. That example, I'll probably do a quadratic equation because it's a good one to do. But solving for the x-intercept, the y-intercept, graphing it, and to graph it, remember, you have to be able to find the inverse, where it's either a maximum or a minimum. And really, quadratics were also part of transformations, right? We used a lot of quadratics to do the transformations, to go, left 2 units, up 3 units. What does that look like? And we used a quadratic function to do that. Okay, we used a quadratic function to do that. Okay. Any questions before I go to the next page? Okay, and you guys can come back and watch this and write it all down if I'm going too fast. But these are all the topics for really about the first half. The second half, which kind of maybe less topics but bigger, each individual topic kind of took a little bit longer, was finding the zeros. And inside that finding the zero section, we had to know how to do synthetic division. There'll be a basic synthetic division question where you just have to divide, 2 polynomials synthetically. You got to find all the zeros. And also remember, give all possible rational zeros, where we used the constant and we used the leading coefficient to find all possible rational zeros. This was like around chapter 3, 3.3, 3.4. It's all kind of right in there. And then rational functions, the fractional functions. And so finding the domain, which really can be in this section as well. Finding the domain in an equation and finding the domain of rational functions are the same. Where I give you a function, I ask you the domain. Rational is when we have an x in the denominator. And then how to find horizontal and vertical asymptotes. And then how to graph that. So how to graph given that we find horizontal and vertical asymptotes. And the last thing, and not the last thing we covered in this semester, of course, that was matrices. The last thing for kind of a review of all the concepts were exponential and logs. First, we did the compound interest question. That's going to be on there where, I'll give you the equation. You just have to plug it in, but you have to know what to plug in. So the compound interest question, simplifying logarithms, and that was really 2 sections. That was like 4.2 and 3. Solving logarithms, which was 4.4, and then writing them in both forms. That was 4.2 actually. Where we wrote an exponential as a log, or we wrote a log as an exponential, kind of a vice versa thing. But that's all the topics, which is pretty cool. And I will be more than happy to go over the questions that Jenna put into the chat box. You know what? Let me get a piece of paper. Okay. Did you get that down, Chastity? I can see you writing. Are you good? Give me a thumbs up. You can give a thumbs up.
Yes, I got it.
Okay.
I have lots of questions.
Good. That's great. Okay. So, well, I'll start with Jenna first, just because they're in the chat box there. But if I don't cover them, if I don't cover your questions with her, then just ask me. Okay. So first, Jenna said, can we go over x and y intercepts? Yeah, no problem. So if we're given a function, I'm going to use a quadratic. If we're given a function like f of x equals, let's say 2x squared plus 3x minus 4. Now, I made this up off the top of my head, okay? But I know there's one like this on the test. I don't know what the answers are going to be. So let's first ask for find the y-intercept because it's super easy. So if I want to find the y-intercept, remember, you always just plug 0 in for the other variable. So all we have to do is plug 0 in for x for the y-intercept. So 2 times 0 squared plus 3 times 0 minus 4, we wind up with -4. Now, as a coordinate, you would say this is 0, -4. And I don't remember exactly how they write the answer. I'm going to assume it's 0, -4. Okay? 0, -4. Let me switch markers here. Now let's find the x-intercepts. These are going to be a little more intense here. So find x-intercepts. Now to do this, we've got to set y equal to 0. Now remember, this is a fancy way of saying y. So in a way, this is an equation to find y. So all we have to do is set the whole thing equal to 0. Now look, this might factor. I don't think it does, but I'm going to use a quadratic formula. X equals -b plus or minus the square root b squared minus 4 times a times c all over 2 times a, right? And I like to solve it underneath the radical first. I'm just going to pop in my calculator. 3 squared minus 4 times 2 times -4. So 41. All over 4. Now, I don't think 41 simplifies. It's a prime number, right? So because it doesn't simplify, this is actually our 2 x-intercepts. If you want to write them as coordinates, it would be -3 plus the square root of 41 over 4, comma 0, right? And -3 minus the square root of 41 over 4, comma 0. Okay, that's how they would be written as coordinates. So we got funky coordinates, but they're definitely coordinates. These would be the x-intercepts, right?
Mhm.
Interval changing. Jenna, what do you mean by intervals changing? Oh, decreasing. Okay, perfect. So like increasing, decreasing. Okay, I'll draw a little graph over here. I'm going to try to put all 3 of these on this graph, and increasing, decreasing, and constant. Let's see. Okay, so we've got this graph. And remember, to do increasing and decreasing and constant, you always use the domain as your interval of where it's happening, okay? So we're going to use x values on where it's happening. And we need to think of visually, I'm sure I drew like the guy on the roller coaster in class. Do you guys remember that at all? And he's going from left. He always has to go from left to right, okay? He's got to go from left to right. So notice where he's at right there, he's decreasing. So to break this up, to the left of +1, this guy's going to be decreasing, right? Forever from the left, and then he's going to get to 1, and he's going to hit a constant patch right here. So from 1 to, was that 3? 1 to 3, he's going to be constant. He's not going up or down. And then after 3, he's going to be going up. So for this question, let's say it was, A is increasing. I'm not going to write all out because I'm just sick of writing. A is increasing. Well, he does it. He increases right here to infinity, right? So from 3, you got to use x values, but from 3 to infinity, he's increasing. Now we always use open parentheses. So 3 to infinity, he increases. And notice, like once 3 happens, he's moving up. Like remember, he's going left to right, so he's moving up. Decreasing. Well, forever from the left to +1, he's going down. So -infinity to 1 would be decreasing. And then lastly, we've got constant. Well, it's just that in-between spot right there. So 1 to 3. 1 to 3, he is constant. So that's a good example of all 3 of those, actually. Okay. So yeah, in behavior now. In behavior really is dictated by the leading coefficient and the degree. Okay, the leading coefficient and the degree. Like if we looked at, let's just look at this quadratic right here. This degree is even. So therefore, look, if we have an even degree, it's going to go up and up or down and down. It has to be the same for the in behavior on both sides. Okay. So like, I'll have to bring another piece of paper. So if we got an even, what it was like 2x squared plus 3x minus 4. If we have an even degree, skipped a letter. If we have an even degree, it means we're going up and up or down and down, right? If we have an even degree, it means we're going up and up or down and down. Now, if it's positive, leading coefficient, a positive always goes up and to the right, okay, always. So odd is going to be opposite. Odd's going to be opposite. So it's going to be down and then up or up and then down, okay? But look, if we have a positive leading coefficient, it's always going to go up and to the right. So that's how I think of it. I look at the leading coefficient and I say, okay, it's positive. That means to the right, it has to go up. But it's an even degree, so it has to be the same. So this one is going to be up and up. And I'm going to tell you, on the test, I believe when it states the answer, it's something to the effect of rises to the left, rises to the right. They don't use this shorthand notation or shorthand notation. I think the test did too. You know, it'll say like rises to the left, rises to the right. And then, but if we had something like, let's just change it up. Let's say like g of x equals, let's say negative 4x cubed plus 7. Okay, something like that. Negative 4x cubed plus 7. Now look, I know because we have a negative leading coefficient, I'll use another color. When I go to the right, this thing's going to be going down. Negative leading coefficient means it's going to go down. It's an odd degree here, so that means it has to be opposite. So therefore, it's rises to the left, lowers to the right. Okay, rises to the left, lowers to the right. This is in behavior. That's a good example of in behavior. Graphing inverses. Oh yeah, graphing inverses. So an inverse is always symmetric around y equals x. So let's see. If we had
when you do this example for graphing inverses, can you just also tell me what section that comes from in my notes?
It would be the inverse section. Hold on.
Okay, if you don't know for sure, then I can find it.
Yeah, no, I got the book right here. That's it. I can dig it out for you. It won't take me that long. The inverse section is well. Oh, there it is. 2.7, Chastity. It's section 2.7.
Okay, thank you.
Yeah, no problem. Let's just kind of go over let's go over a basic one. Let's say we had f of x equals, let's say x cubed plus 2. Why not? Okay, so x cubed plus 2. So I'm going to graph this. Now you can find the inverse. We'll do that here in a second. But to graph it without finding the inverse, like algebraically, just know that it's going to be symmetric around this line, y equals x. So if I wanted to look, and this is a good example of transformations, we got the x cubed parent function. Plus 2 means we go up 2. And x cubed looks something like this. Okay, x cubed looks something like that. So if I want to graph the inverse, it has to be symmetric around this line. And I didn't really teach it this way. I taught it more like you find the inverse and then graph it, which I think is kind of a better way to do it. But it would go across here and it would look something like this. Okay. See how those two graphs are symmetric around this line? And if you're not really good visually, like in seeing that, let's just find it. So if I found the inverse, remember we do y equals x cubed plus 2. And then the next step in finding the inverse was switching the x and the y. So we get x equals y cubed plus 2. That was the first step. And then we had to solve for that y. So I'm going to subtract 2. I get x minus 2 equals y cubed. And then to get rid of the cubed, we had to take the cube root of both sides. Okay, so I took the cube root, and the y is by itself now. This is going to wind up being my inverse function. Okay, the cube root of x minus 2. Now, if I wanted to graph this, and this is another good example of transformations, this minus 2 is inside the function. And remember, if it was minus inside the function, we went to the right 2 units. And the x cubed looks like this, or the cube root of x, I should say. The cube root function looks just like this. And you would graph that same graph, okay? But they're always symmetric around y equals x right there. And we've got the cube root of x minus 2. So let's say this question asked, it gave you a function and asked you, what is the inverse? Boom, that's how you solve that. And then if it asks you to graph it, that's how you would graph it, using kind of transformations or understanding the symmetry around y equals x.
This is one of the things I actually needed a lot of help with. I don't know why I don't get it.
Is that?
This is just one of the ones I need a lot of work with.
Yeah. I mean, did that help seeing that? Do you remember going over it?
Yeah, yes. And I have it in my notes and stuff, so I'll just have to practice.
No, yeah, and I'll tell you, practice is good. And like finding, if you go back in and watch that section, go back to the video that I made on 2.7, we go over that, right? Big time. I remember doing quite a few examples of finding the inverse function. Graphing the inverse. And then multiplicities, like crossing and turning. Okay, let's look at a basic example of that. It's when you have an even, when your zero occurs an even amount of times. So let's use another color here. Let's say I've got f of x, and I'm already going to factor this. So this is going to be x minus 3 squared and x plus 1, just x plus 1, okay? If I ask you to find the zeros and state their multiplicities, well, what's nice here is that these are already factored. So to find the zeros, let's say find the zeros, we'd have x minus 3 equals 0, so we know x equals 3 is one of the zeros. X plus 1 equals 0, so x equals negative 1 is another 0. Now, the degree up here that's attached to the factor, that's the number of times it occurs. So what this tells me is that this occurs twice, the x equals 3, so its multiplicity is 2. This only occurs once, right? If you want to write a 1 there, you're more than welcome to. So its multiplicity is 1. If we wanted to graph this, we need to find end behavior, right? Well, now look, the multiplicity is 2 and 1, so we have 3 factors, right? If I wrote this out, it would be x minus 3, x minus 3, x plus 1. So we've got a degree of 3 with a leading coefficient that's positive. So my end behavior is going to go up and it's going to go down over here. So let's just wait first, before we even do that, let's just show where these cross. So this is going to cross here. It's going to bounce there, okay? The end behavior means that this leftmost 0, we're going to go down here, and the rightmost 0, we have to go up here because the end behavior is down and then up. Now, look, the multiplicity for negative 1 is 1, so that means it crosses here. So it's going to go up, come back down, and then the multiplicity at 3 is an even number, so that means it bounces. so it touches. Your book uses the word, I think it would use the word touch or turns around, something like that. And I like the word bounce because it sounds cooler. Okay. Okay. I hope that helps, Jenna. I think I've covered everything you've asked me to cover there. Okay, Chastity. What are you thinking?
That's what I'm going to look at.
Or anyone else. I mean, if you have other questions, pop them into the chat or just chime in. It's no big deal. We've got plenty of time to cover stuff.
So I'm basically just going to look at what I got wrong, and it was just test 2 and test 3 that I struggled with, and we just went over a lot of it from. Let's see.
Yeah.
I did want to go over just one example of finding zeros, even though I know I have it in my notes and videos.
Yeah.
Actually, no. I know how to find zeros. Actually, I'm good with that. Okay. I needed the transformation, the inverses, and then the f of g. I don't remember what that was called. What that was.
Oh, the composition stuff?
Yes.
Yeah.
Yes. That. Is that going to be on the final?
Yeah. It was the composition with, yeah, it's on there.
Okay. So then I just need that one.
Yeah. Okay. So if we go, let's say we got f of x equals 2x plus 1 and g of x equals 3x minus 4, something like that. Okay. Mm-hmm. And I ask you to find the composition. Now, order matters, right? That's really what composition is about. So let's do both. I'm going to do, first, I want you to find f composed of g.
Composed of g. That's what I couldn't remember.
Yeah, f composed of g. And really, what matters here is we're taking that second function and we're plugging it into the first function. So for this example, we're going to take all of this second function and we're going to plug it into that x value. So 2 times 3x minus 4 plus 1, right? Do you remember this now?
Yes.
Good. So we distribute the 2 and we get 6x minus 8 plus 1. And we wind up with 6x minus 7.
Okay. I do remember that.
And if they ask you for like f composed of g of 2, you just plug it into that function, right? So 6 times 2 minus 7, so 12 minus 7, so you get 5. Okay? So if they ask you for a number, you just plug it into what you found.
Gotcha. That's simple.
Yeah, it's not bad. And, you know, a lot of this stuff is just because we haven't seen it in a few months, right? I mean,
yeah. That's definitely the problem I'm having. But I do have all my notes, and so I just thought maybe the most important question for me is where to find everything.
Oh yeah. Well, okay. I'll tell you what what'll help with that is the schedule. If you go to the schedule in Blackboard, because it tells you which sections were covered on what test.
Ah, okay.
Yeah, that'll probably help you. And you're right, because sometimes it's like, what did that? What was that called? Oh yeah, it's composition. You know. Okay, Sherry, I see you there. Let me find the question, because I don't mind just going over that exact one. Let me dig it up here.
I like those ones.
I was doing this for my business stat class this morning, and they found a question that was wrong that I put in wrong. So I'm telling you, it's good. Now yours is going to be harder to do because I use a test generator software, like the publisher comes up with it. But I did think that was kind of funny. You could tell, like after that, they were going to scrounge through every single question to see if I goofed up. Okay, you said test 4. Let me get in there. Test 4. Yeah, Jenna. Let me get back to that. The radioactive question. Okay, here we go. So I'm reading this from test 4. It says the function f of x equals 500, not 5,000, Then 0.5 raised to the x divided by 80. This models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put in the vault. I'll just say years in vault. Find the amount of radioactive material in the vault after 60 years. So really it's saying, when x equals 60, we want to know what's f of 60, right? So let's plug that in there. So we get f of 60 would be 500. Now I'm going to write this exactly how I would write it in the calculator. So because I'm going to have to use the calculator, Sherry, for this one. So I'm going to put 500 parentheses 0.5 caret, and then now we're putting 60 for x, right? So I'm going to say 60 divided by 80. Now, if your calculator automatically puts the exponent up there, in the exponent, you're going to put 60 divided by 80. So let's do that. So we've got, there we go, 500 parentheses 0.5 caret. And then mine automatically does the exponent. 60 divided by 80. I'm going to make sure that 60 divided by 80 is all in the all in the exponent. So if yours doesn't do the exponent automatically, you're going to have to make sure it's in parentheses. If not, it's going to raise it to the 60 and then divide everything by 80. And you don't want that. Okay, when you do that, you get 279.3. Oh, it rounds to the pound. Yeah, round to the nearest whole number. So 297, not 79, 297. So if we round to the nearest whole number, it's going to be 297. Okay. Does that help, Sherry? Give me a thumbs up or yes. Or just say, you're the best algebra teacher in the whole world. Yes. Okay, just yes. Okay. Okay, Jenna asked, hey, that end behavior question with the multiplicities, how did you get that? Yeah, I don't mind going over that. So if something's already factored, it's kind of nice, but you can't see the leading coefficient as well. So if I go back to this one, I believe it was x minus 3 squared and x plus 1, something like that. So if I ask you the end behavior given in the factored form, oh, how about the accurate? So I need your brain to think of it like this: x minus 3 times x minus 3 times x plus 1. Okay, and to get the leading term, which tells us the end behavior, all you have to do is multiply the leading term in each one of these parentheses. So the leading term is going to be x cubed. Now I knew it was going to be cubed because there's 3 factors. That's what I talked about. I think when I kind of just spewed it out whenever I was lecturing, I said, oh yeah, there's 3 factors. That's a degree of 3. So that degree of 3 tells me it's opposite. Now the leading coefficient right here, it's actually here as well. There's a 1. So it's a positive 1. So I know the end behavior here, it's going to go up because the leading coefficient's 1, and it's opposite because it's odd. So it rises to the right, falls to the left. Okay, that's where I got that, Jenna. And then I think in the example, if you know that, it was like -1 was one of the zeros, 2, 3. The other one was 3. You know from those zeros what's happening. The leftmost 0 has to go down. The rightmost 0 has to go up. And then I think for this one went through, yeah, and then it bounced, right? Okay. Does that help, Jenna? Do you have any other questions about that one? I don't mind staying on this one for a minute because it's a good example. I'll give you a second to type it in there. Oh, that helped. Okay, great. So Sherry asked about the compound interest example. Yeah, let's do one of those. Let's say, you know what? Let's look and see, just because I want to know. Let's see what the Powerball is at. Test 4 had them. Oh yeah, that's fine. I'll make one up. Powerball. Ooh, the test 4 questions though is different. Test 4 dealt with it. Okay, we'll do 2 different kinds of compound interest question than Sherry. The Powerball, not numbers, I want the Powerball payout right now. So the Powerball, why is it not just telling me what the total jackpot is right now? 231 million. Oh, that's beautiful. Okay, so let's say we won the Powerball. And after taxes and paying off stuff, we have like $100 million, right? And then we're thinking, you know what? $100 million, this is awesome. Now that would be considered the P, 100 million. I could just spend it all. Oh, there's more zeros. I could just spend it all on cool stuff, helping people out and buying a bigger boat. Or I could invest it and then be able to help other people out and buy bigger boats throughout my entire life. So let's say you do that. Let's say you take this $100 million and you invest it. And this is just for theoretical purposes. If we put in the market, let's say we can expect to get 8.5% return. And let's just say it's compounded monthly, just for fun. Now remember, that means we're going to do 12. And let's see what happens after 1 year. Just for 1 year to see how much money is in there. And then maybe what we can do is we can live off that interest, right, after 1 year. So the formula, which I'll give you, now this is compounded non-continuously. So it's A equals P, parentheses, 1 plus R over, is it R over T? Yeah. No, that's not right. Huh. Is it R over T? No, it's N over T. That's why it doesn't seem right. N over, no, it's not. It's R over, oh my Lord, I can't believe I forgot this. This is something I do all the time. It's R over N. Good God. Wow. We'll blame that one.
And then it's raised to the N times T, right?
Yeah, raised to the N times T. Blame that on the pandemic, sure. I've been writing that over a decade now. That's weird that anyway. But look, we've got everything we need for this formula, right? So I'm gonna put this in just like I would in the calculator. So 100 million times 1 plus, now the rate, remember we have to write the rate as 0.085, right? We have to write it as a decimal. So 0.085 divided by N, which was 12, raised to the 12 times 1. Okay, so I'm going to pop that in my calculator. I'm going to see what's in this account after 1 year. So 100, gosh, that's a lot of zeros. 1 plus 0.085 divided by 12 raised to the, well, 12 times 1 is just 12, right? So you wind up with 108,839,090. So let's do the, I guess 0.60. There, yeah. So you wind up with 108,839,090. So what that means is if you can get 8% on your money or 8.5% on your money compounded monthly, you could not even touch this base and just live off $8,839,090 each year, which would be awesome, right? I mean, this is theoretical. Uncle Sam's going to take that part of that money too, but I won't complain I won't complain if Uncle Sam took, if I still get like over $4 million after Uncle Sam takes something, I'll be happy. Okay. Especially when it's just sitting in a bank account. It's not like, this isn't like us investing and risking and blah, 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 blah. Okay. But anyway, tangential stuff. But anyway, so this is a good basic example of a compound interest question where I give you the amount to start with, really the principal, the rate, the number of times it's compounded yearly, and then the number of years it sits in there. It sits in the bank account. Now on test 4, let me dig in there, Sherry. Oh, I was in test 4. Gosh darn it. Oh, that was the one in test 4. You were right, Sherry. I was thinking, good gosh. Yeah, this is just like the one from test 4, right? Maybe they did, if it's a If it's compounded continuously, it's a little easier. So let's look at one that is just compounding continuously. So let's say we've got, instead of hitting 100 million, let's say we, I don't know, it doesn't matter. Let's say we've got 4,000. And our rate is like 7.2%, but it's compounded continuously. That's the big indicator. If it's continuously, it's going to be another equation. And let's say we're going to leave it in for 5 years this time. Okay. So if it's continuously, the equation looks like this. Hopefully I can remember this one. A equals PE to the RT. Okay, PERT. But RT is in the exponent. So this would be 4,000 E raised to the 0.072 times 5, right? 4,000 E to the 0.072 times 5. And again, I'm not making you memorize this formula, but you'll need to know, like I'll give you both these formulas, and you'll need to know, okay, hey, this is one says it's raised, it's continuous. That's got to be that formula, not this one. Okay. So let's check this out. 4,000 E to the 0.072 times 5. 5,733 and 31 cents. So after 5 years in that account, you'll have $5,733 and I guess 32 cents. Ooh, 32 cents. Does that help, Sherry? How did you get the E? Oh, yeah, the E on the calculator is, I think you have to hit second LN right there. So you got to hit the second button and then LN. And it brings it up. Second LN. It's right there by the 4-ish, kind of over there. Got it. Perfect. Great questions. Okay. Any other questions? These are good. You guys asked a lot more questions in my first class. You will be mucho more prepared.
When you were talking, when we were doing the F composed of G, you started to say something about if it said F composed of G of 2. How would that one go?
That was the second example of it. Hold on. So like if they ask for F composed of G of X, we just plug it in, right?
Mm-hmm.
Or we found it. Well, if they ask for F composed of G of 2, so instead of an X value, it's 2, you can just find F composed of G of X and then plug in the 2 value. Plug in whatever value's here.
Oh, we just plug in the 2 right there on.
Yeah.
Okay. When we already.
Yeah.
Okay, that's okay. Yay. Thank you.
Yeah, no problem. No problem. Questions, comments, questions about anything. It doesn't have to be about the test per se. I'll tell you, so, the test opens Friday. If you want to send me an email asking questions, you're more than welcome to. And also tomorrow, and I know not all of us can meet this. Oh, hold on. I'll let you know, Sherry. Give me 2 seconds. Tomorrow, I have a Thursday class from 9:25. It's till like about 10:20. When is it? 10:35? I forget. No, 10:40. Till 10:40. So, and you click on the same button that you get into this class. It's the same thing. So if you think of a question, you can come in at this time. I'll be doing the same thing I'm doing in here. So you're more than welcome to come in and sit in and see what questions they ask. I'll tell you, you guys have asked pretty much the whole test. There's not much you haven't asked about at all, but you're more than welcome to do that. Hold on, let me. Okay. So Sherry asked me about fewer classes for the spring. No, I don't think there's fewer classes being offered. It's just that we're seeing more students um, fill up the online classes first. We're traditionally, this semester was just so weird. And I'll tell you, it started off chaotic. So it was already kind of in a weird spot when we started. Well, we really hammered down how the classes are going to be taught in the spring. That was something we worked on as faculty with our dean and administration. So therefore, there wouldn't be as much confusion to begin with. So each class, it's laid out when you get into the class exactly how it's going to be offered. And because of that, I think there might be less online offerings, but we have more offerings like the one we're doing now, where like I know I'm teaching college algebra just like this next semester, where you can come to class, you can not come to class, you can Zoom in at that time, whatever, really set up the same way we do now, but at least students know about it ahead of time because it was such a chaotic craziness at the beginning. You guys know, we all lived through it. It was just a crazy month there at the beginning. So I don't think there's necessarily fewer offerings. I think what's happening is we have less like pure online offerings, and a lot of students want online. A lot more students are wanting online. I think now because that way you just know how it's going to be taught.
Can you hear me okay?
I can hear you perfectly.
Okay, I never know. I have my laptop closed using my monitor to work, so I don't know if you can hear me.
Yeah.
I was just looking because I'm getting close to what I can do here at ASU.
Yeah.
Versus having to go ahead and transfer, and I'm down to like some religion and humanities stuff.
Okay.
And I could only find one humanities class. And so I really don't know even how to look for those because when I pull up the course list, it doesn't.
Hold on. I don't mind helping you out at all, Sherry, personally. If you just sit tight.
Okay.
I'll be happy to help you. And if people want to stay here and watch me help Sherry, you're more than welcome to. But I just don't want to record it because I might have to I'll have to look a little deeper.
Okay.
But yeah, no, sit tight. I will definitely help you with that. I don't mind helping at all.
Okay, great.
I swear I've gotten grayer throughout the semester. Look at that. Oh God, I need some just for men. Just for parents going through the pandemic. That's what that is.
We all have, yeah. I definitely have a few more grays this semester.
Yeah.
I don't have any more questions if you don't have any more information.
No. What do you say?
My son said it's just old age, but he's
old age, is wiser. You're becoming wiser.
Yeah.
Like the smashing of the grapes in the wine, right?
Yes. Okay. Well, everybody, good luck with your test then.
Yes,
You
I'll
too.
see you guys. Sit tight. Hey, and if anybody wants help with advising, I don't mind right now. I can help you all.